Hi guys, so this is for module 5 through 6 for triangle congruence. If we're looking at number 1 here, we see two triangles and they go ahead and say that they're congruent. Awesome, okay. That means each corresponding side has to be congruent to the other corresponding side. If it's a corresponding angle, the angle's got to be corresponding. So 45 is going to be corresponding with the other 45. The 55 is going to be corresponding with the other 55. And if CPC TC is being curved here, which it should because we have, um, again, the fact that these guys are for a fact congruent, these two triangles are congruent, then therefore, basically, angle, or the measure for angle L should be congruent. Whoa, touchscreen, thank you. Congruent to the measure for angle P. Okay, for the measure of angle P. All right, so knowing that, we have to find what L is. Okay, so let's find that. Now, we do need to know that the sum of all the interior angles of a triangle should add up to 180. So knowing that, we can find L. Okay, so you can do it several ways. You can take the 180 that you know you have, subtract the 55. Okay, and this is in the calculator, so 180 minus 55, and you should get 125. Then subtract the 45, the other angle that's already given, okay? And you should get 80, okay? So that's 80 degrees. So the measure for angle L is 80 degrees. Now, knowing that, angle P also has to be 90 degrees, but we're looking for the value of x. So basically, we're going to set this expression they give us, 5x plus 30, equal to 80 degrees. And then we just solve. So subtraction property, just like in algebra, these cancel out. You're left with 5x equaling 50 degrees. Division property, what you do to one side, do to the other, and x equals 10. All right, so again, x equals 10. Awesome. And then they're asking you for the measure of angle L, which we said was 80 degrees. Okay, so notice here we actually had to apply the idea of CP CTC. Okay, each little part has to be matching up with the corresponding part, and in this situation it was L that was corresponding with P, which has to be congruent because Y, they told us. Okay, and then again, the other idea is the sum of all interior angles of a triangle have to add up to 180. So that is the triangle sum theorem. Okay, so don't forget that. All right, I want to be honest with you. This one is basically very similar to number 1. Okay, so number 2 is very identical. So who's to who? Okay, so they already tell us that these guys are resulting in congruent triangles. So go ahead and figure out which part is to who. And then solve for x, solve for y, and then plug them back in, find your missing pieces. Okay, so this one is practice for you. This is homework. Okay, so try that one out. Okay, again, look at number 1, and it's very similar in each little part. Okay, also realize that you have this expression here, 2x plus y. You're definitely going to have to figure out what x is in order to solve for y. Okay, so just be aware of that. Start with x. All right, number 3. So proofs. Okay, these are good. Proofs are good. So let's see, what theorem would prove that these two triangles are congruent? What information to use to prove it? Okay, that's good. So they already give us, and I'm going to go ahead and do the whole two-way table. Okay, so again, I got my statements. I want to get my reasoning over here on the right. My reason, okay, or justification. They already say this, all right, A is congruent to C, angle C, so this guy right here is going to be the same as here. Notice how I'm marking them. That's very good to do. Okay, so that was given. They straight up just told us right away. How nice of them. Okay, and that was given. All right, and then E is the midpoint of AC. Well, okay, if E is the midpoint, then these two should be congruent. Okay, notice how I marked it real quick. So I'm going to go ahead and write out what I just marked. Okay, so again, E is the midpoint. of AC. Again, that was given. How nice of them. And then I immediately was like, wait, that means that BE, okay, is going to be congruent to DE. Touchscreen failure? Whoa, what is that? No advertisement, go away. How rude. Okay. To DE. And because they're congruent, that is because that's the definition of a midpoint. Okay, so be aware of what it means to be a midpoint. All right, so let's see, we have an angle. All right, we have a pair of angles. Thank you, touchscreen, for making my day funner. One of these days I'm going to figure it out. And then we have side and another side. Okay, so we found that. What else do we have? Just look at the picture. Okay, well, look at the picture. I see vertical angles, right? Do you guys see them? So it looks like angle AEB is going to be congruent to the other angle DEC or CED. It's really up to you on the positioning there. And that's because they're vertical angles. Okay, so for the original question, what would prove, what theorems would prove? Well, you got the definition of the midpoint, you got vertical angles, okay, you got those kind of things going on there. And then what actual triangle congruence do we have here? I see angle, angle, side, angle, angle, side. So yeah, we're using angle, angle, side. So triangle AEB is congruent to the other triangle, CED. And that is because by, whoa, that is strange. By angle, angle, side, triangle, congruency. Congruence theorem. Just writing it all out. There we go. Okay, so that's actually the theorem that I think the original question was asking, but notice the proof just kind of articulates it. So again, we get an angle from what was given. We have a pair of sides from the midpoint. Okay, sorry, that belongs one step lower. And then another angle from the last thing that was given for us right here. Now I know you're like, what? That spells ASA, but if you look at the picture, okay, at the figure, in sense of order, we have angle, angle, side, angle to side. That's why it's angle, angle, side. Okay, it's all about positioning. All right, this one, okay. Notice how they give us a word bank. Okay, so that's good. Not all need to be used. Oh, okay, that's nice of them. So if we look here, we have just looking at the picture. What did they give us? They gave us that S and U are right angles. Ooh, okay. Usually when they say that, I'm starting to think like, is HL triangle congruency going to come in? All right, so let's find out. Let's see, right angles, they're given. Very nice. And that means that angle S is going to be congruent to angle U because 90 degrees equals 90 degrees. Sorry, that's the angle system symbol. And then RV bisects SU. They gave that to us. Okay. And then therefore ST is congruent to UT. Well, they didn't say that. That's not given. Okay, typo. Okay. ST is congruent to TU because again, that is the definition, okay, of a bisector. Bi means two. two what? Two sectors. Two, in this situation, two line segments that are evenly divided in two. All right, angle RTS. RTS is congruent to what? Okay. That actually doesn't really help me too much. Yeah, they're right triangles. But if you look here, all we have is a leg, right? That's congruent to another leg. And yeah, they're right triangles, and we really need to find a hypotenuse for HL triangle congruence. But notice how the proof here is not talking about another side. It's not talking about the hypotenuse. It's talking about an angle. Okay, so they might be throwing a curveball at us. Well, if we look at the image, supposedly, if they're saying that RTS, oops, sorry, I completely read that one wrong. It's late, guys, come on. All right, so they're talking about these guys, all right? And I'm thinking, okay, those are definitely going to be vertical angles. So they're talking about angle RTS congruent to UTV. Thank you, touchscreen. I really, really need to fix that or figure out what that is. I think I need to write an email to the company. There we go. And that again is because of vertical angles. So let's see, it didn't even have it in the word bank. That's interesting. Okay. Vertical angles. Okay, and then basically they say these guys are congruent, which means it doesn't look like they're using HL triangle congruence. What did they end up using? Well, let's see. They gave us an angle right away. We found a side, and then we found another angle. Okay, so we had the angle, we had the side, and then we had the angle. And same thing here. We had the angle, we went to the side, and then last but not least, to the other angle. So it looks like we used angle, side, angle, triangle congruence theorem. Okay. All right, so be aware, sometimes you'll see a right triangle and you might want to initially think, hey, that's definitely HL triangle congruency for sure. But it really depends on what they give you or what they start leading you off with, okay? So just be aware of all the possible scenarios, okay? All right, let's see. So number 5, what would you need to know if you wanted to prove that these triangles are congruent by angle, side, angle? Okay, well, let's see. We have an angle here. We have an angle here. We have an angle here. We do need to know the angle for angle B there, right? Ooh, I just realized we have an angle here with an angle here, and we have a side given to us. We have a side given here and an angle given there, and let me erase the rest of it so you're like totally knowing what I'm talking about. I already see this, okay? What more do we need for ASA, for angle, side, angle? What about this guy? Angle D, right? EDF. So it would totally be angle EDF being congruent to angle BAC. Okay, so notice how I'm being very specific. Angle EDF has to be congruent to the one I just marked right here, which is BAC. If that happens, we're good. All right, we got ASA, angle, side, angle. All right, part B, what do you need to know if you want to prove these triangles are congruent by angle, angle, side? So let me erase all my little work here. If you already wrote this out, just use a different color. That way you're not tripping over the idea here. All right. Let's see. Okay. Whoa. That was a weird hiccup. It's weird. My computer's just like, wait. It's like, no, computer, I'm not going to wait. All right, there we go. Angle, angle, side. Okay, so let's see. We have an angle here. We have an angle here. So far, so good. And then we have a side here. Haha. So this triangle's already, showing signs of angle, angle, side. But if we look here, well, yeah, we got our angle here. Okay, matching up with this guy. That's great. And then we have our side here matching up with the other guy's side. That's wonderful. But we need an angle in front of the other angle, which means we need to find angle ABC. Okay, so we need to know for a fact that angle ABC is congruent to the other angle DEF. Okay, so we need to know that this angle is corresponding to the other angle. Okay, so that's what we really need to know. All right, so I'll tell you what, I want you guys to test yourselves, test your metal. Try number or part C as homework. Same thing with D. Now, could we use hypotenuse leg congruence theorem? We would have to change a lot, right? Because hypotenuse leg theorem relies on 90-degree angles. No, unless we change the angles, right? For a 90-degree angle. Okay, aka a right triangle. And what's really weird is I'm writing right now and my computer is like not even registering what I just wrote. I'm pretty sure it's just going to blob on the screen all at once. Yeah, I think it's going to do that in like any second now. Oh, upsetting. Wow. That is not what I wrote. Nice try, computer. Supremely disappointed. Okay, aka right triangles or right angles. Okay, so if we had something like this, not like that, something like this, then yeah, we could have a conversation about it. We might have a leg and a hypotenuse matching up with some other, right triangle that has a leg and a hypotenuse. Yeah, that would be the only case where it would work. But we don't. We don't have any 90-degree angles. Those are definitely not right triangles. All right. So here's looks like more practice. Um, tell you what, we already know we have to solve for x here. So, wow, touchscreen fail. All right, there we go. So, let's see. Y, y equals that. Z equals that. Okay. Hmm. Okay. Let's see. That's 90. So notice what I'm doing. I'm actually just trying to look at it. I'm looking at the picture, and I think that's y over 5. I'm hoping that's y over 5. Okay, so it looks like we can solve for x. Okay, if this angle is a right angle, then this angle is a right angle. We have a 30 and a 90 right here, and we know that all the interior angles add up to 180. That means that we have 4x plus that 30 degrees plus that 90 degrees has to add up to 180 degrees. Again, that's the triangle sum theorem. So we're going to combine like terms using good old-fashioned algebra. And we're going to use the subtraction property, okay, of the 120, the 60 there. We're going to use the division property, and we're going to use the eraser to get rid of whatever that was. And we're going to get x equaling 15. Sweet. All right, so x is definitely going to equal 15. Good. Now I could just substitute in and start solving for everything else. Now, if I was to plug back in 15 for x, I would get 60 degrees for this angle. That's something to definitely do because you do want to solve for y later down the road, okay? So we already know x, all right, we have the 2x. We're going to solve for, I'm going to try to solve for y right now, okay? And that's using this part, okay? Notice how they have this part and they have this y right here, but I'm just trying to see what I can work off of because in the back of my head, I'm thinking CPCTC, all right? I'm thinking about the corresponding parts. I'm thinking, okay, this part had to be 60. That means this guy has got to be 60 because he's corresponding, right? So I'm thinking CPCTC. All right, so 2x. Wow, touchscreen. I am super going to try to figure that one out tonight. This is the worst it's ever been. 2x plus y equals 60 degrees. Okay. X is already 15, and we know that 2 times 15 is 30. So we got 30 here. 30 degrees plus y equals 60. We're going to use the subtraction property. All right. Both sides, what you do to one side, do to the other. And we're going to have y equaling 30. Good. So we just found another variable. All right, that's really good. And now we can actually solve for z. All right, we have y, z together right here, and they should be congruent to this 30 degrees right here because y, well, CPCTC, okay? Um, so let's go ahead and do that. We have we have y, z, and they should be equaling 30 degrees because of the whole CPCTC. And y, we already say, is 30 degrees. So 30 times what, or z, equals 30. Oh, that's just division property. And look at that. 30 divided by 30 is 1. So z equals 1. And then basically from there on, all you have to do is plug and chug. Okay, so for example, for angle A, we already found that to be 60 degrees. Angle B was actually given to us because, you know, they just had it in the picture. Angle D is also going to have to be 60 degrees. Okay, and that's good old CPCTC. AC, which is 8 times Z, is really just 8 times 1 because Z equals 1, and 8 times 1 is 8. Okay. CD should be congruent to AC, so it's also going to be 8. BD, okay, we actually don't have that yet. I think we're going to have to use Pythagorean to get that because we do have right triangles. So I'm going to skip it for now. AB is definitely going to be the same as BD. BC is just y over 5, and y we said was 30. So to find BC, okay, I'll show my work over here for BC. We have y over 5, which is really just, well, y is 30, and what's 30 divided by 5? 6, all right? So BC is 6. All right, so let's go ahead and find BD and AB, which should be the same, okay? We have to use Pythagorean theorem. So if I use Pythagorean theorem, that is basically just a squared plus b squared equals c squared. And I'm going to put it in context with our triangles. We don't know what AB is or BD. I'll just use, for my hypotenuse, instead of C, it's going to be BD. Okay, BD squared. Okay, we don't know what it is yet, but we know it's the hypotenuse. We know that CD is 8. So I want to have 8. Okay, wow. There we go. So we're going to have 8 squared, okay, because again, the CD, which is right here, okay, and then it's going to be plus um, what we have for BC, which again for BC we have 6, which is right here, and we're going to square that as well. So we have 36, because 6 squared is 6 times 6, 8 squared, which is 64, because 8 times 8, equaling BD squared. We're going to go combine like terms. So 34 plus 64 is 100. And we're going to get rid of the square, which just means square root. We do to one side, do the other. And looks like BD is going to get us 10. Now, if BD is 10, AB is also 10 because we're told right away by the picture they are the same. All right. All right. How can you prove that these triangles are congruent? They only say that it's a rectangle. Well, if you know what a rectangle means, it means that AC is going to be the same length as BD. AB is going to be the same length as CD. Okay. So notice how we just know about the properties of a rectangle. We already know some sides. All right. I know this side is going to be corresponding to this side, and this side is going to be corresponding to this side. But what else? Well, isn't BC being shared by both triangles? That's the reflexive property. So in a way, we get a freebie. We get a free side. So it looks like we got side, 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 triangle congruency. Okay, so how can you prove these guys are congruent? Well, first things first, you have to know the definition of a rectangle. Wow, touchscreen. I'm this close to just grabbing my touchscreen and throwing it as far as I can out this window. Rectangle. Oh. You know, I really have patience for kids. Like, I really do. I love working with kids. It's so fun. But this touchscreen, oh boy. Definition of a rectangle. Okay, definition of rectangle, right? And then we use the reflexive property to say that, well, BC is congruent to itself. So you got to remember the reflexive property. It's so important. So many kids just forget it, and it's like, oh, you have no idea how close you are to the proof. You just need one more side, and the reflexive property helps with that. Okay, so after that, you have side, 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 triangle, congruence theorem. All right, looks like I knocked out all 4 pages. If you guys have any questions, let me know. And yeah, try the homework problems. See how much you know. Okay. All right, guys. Have a great day. And if you have any questions again, just let me know.